Ever wondered how devices talk to each other without Wi-Fi or cellular networks? Welcome to the world of mesh radio networks. To put it simply, imagine a vast web of devices, each one a tiny radio station transmitting and receiving information. This web, or mesh, isn't reliant on a central hub like traditional networks. Instead, every device, or node, communicates directly with its neighbors. This creates a self-healing network that automatically reroutes data if a node goes offline, ensuring uninterrupted connectivity. Picture a bustling city with countless intersections and alternative routes. If one road gets blocked, traffic simply diverts along another path. That's precisely how mesh radio networks operate. They are like a digital version of Pass the Parcel, where each device or node passes on the data to the next, ensuring the message reaches its destination. So in essence, mesh radio networks are like a giant game of digital Pass the Parcel, with each device playing a critical role in keeping the network alive. Now, let's dive into the mechanics of these networks. Imagine a vast web where each strand is a device or node in a mesh radio network. These nodes are unique because they function both as transmitters and receivers. When a node needs to send information, it doesn't send it to a central hub like in traditional networks. Instead, it sends the data directly to the closest node within its range. That node then does the same, relaying the information to another node. This process continues until the data reaches its final destination. This pass-the-parcel style of communication creates a seamless network where data can zigzag its way across nodes, always taking the quickest or least congested route. And if a node becomes unavailable, the network self-adjusts, finding a new path to ensure the data gets where it needs to go. So every device in a mesh radio network is a vital part of the communication chain, helping to relay data from point A to point B. But what makes mesh radio networks so special, you might ask? Well, let's dive into just why these networks are a game changer. Firstly, their reliability is unparalleled. Each device or node is both a transmitter and a receiver, creating a self-healing network. If one node fails, data simply finds a new path, ensuring seamless communication. Secondly, these networks are highly scalable. Whether you have 5 nodes or 500, the network adjusts and expands effortlessly. Finally, let's talk coverage. Traditional Wi-Fi or cellular networks can be patchy, especially in remote or difficult environments. But mesh radio networks shine in these situations, providing consistent, strong signal strength. These networks aren't just robust, they're versatile too. They can function in the heart of a bustling city or the depths of a dense forest, adapting to the demands of the environment. In other words, mesh radio networks are like the Swiss Army knife of wireless connectivity, versatile and reliable in a variety of situations. But where do we see these networks in action? Well, mesh radio networks are all around us, invisibly weaving a web of connectivity. Picture your smart home devices. These gadgets often form a mesh network to extend Wi-Fi coverage throughout your home, ensuring your smart speaker in the living room can communicate with a smart light bulb in your attic. Moving beyond the home, consider remote areas. Traditional infrastructure like Wi-Fi or cellular networks might be impractical or impossible. Here, mesh radio networks shine, providing critical communication lines in challenging terrains, whether it be a mountain range or a dense rainforest. Emergency services also utilize mesh radio networks in disaster scenarios. When traditional communication infrastructure collapses, these networks can provide a lifeline, enabling rescue teams to coordinate their efforts effectively. Thus, mesh radio networks are not just a theoretical concept but a practical solution to real-world connectivity challenges. However, like any technology, mesh radio networks have their challenges. One of the main hurdles is interference. With multiple devices communicating simultaneously, the airwaves can get crowded, leading to signal disruption. Another issue is power consumption. As each device acts as both a transmitter and a receiver, the energy demands can be substantial. But don't fret, solutions are in sight. Advanced network design and optimization can mitigate interference, ensuring smooth communication. And as for power consumption, innovative energy-saving technologies are being developed to make mesh radio networks more efficient. Looking ahead, the future of mesh radio networks is exciting. We can expect improved energy efficiency and faster data transfer speeds. Moreover, integration with emerging technologies like the Internet of Things is a thrilling prospect. Imagine your smart fridge talking directly to your grocery app, ensuring you never run out of milk again. Despite the challenges, the future of mesh radio networks is bright, promising faster, more efficient, and more innovative ways for our devices to communicate.